Welcome to qnawire.
So this problem requires some unique thinking. We have a sample that has an activity of 175 nanocuries per gram. Okay, we can convert the nanocuries per gram into curies per gram. And the reason we would want to do this is because we have two different activity units. We have an activity for the sample in curies per gram and an activity for the solution in becquerels per milliliter. So not only are the denominator units different, but so are the numerator. So let's first convert our curie units into becquerel units so that we can make a direct comparison. So once we get into curies, we can go to becquerels, and at this point we would have units of becquerels per gram of AgCl. But it's just the silver that is active, radioactive, and it's also more helpful to know the not just mass of silver chloride or not just mass of silver, but the number of radioactive silver nuclides. So we can convert the grams of silver chloride into moles of silver chloride, which is more representative of the number of silver chloride formula units. We can then convert the moles of silver chloride into the moles of just the radioactive element, which is silver. So now we have units of becquerels per mole of silver. Let's see if this is helpful with the subsequent information that was given in becquerels per milliliter. So this calculation up here gives us 9.28 times 10 to the fifth becquerels per mole of silver ions. Once the solution forms, we know that the activity is 1.25 times 10 to the negative 2 becquerels per milliliter. Well, now that we know becquerels per mole and becquerels per milliliter, hopefully you can see where we're going with this. We can now get a concentration unit by having the units of becquerels cancel. So if I take what I calculated up here as becquerels per mole of silver ions, and then allow my becquerel units to cancel by putting in the numerator moles of silver ions and in the denominator becquerels, then I will end up with units of moles of silver per milliliter of solution. So I'm almost there. Then I'll go from milliliters of solution to liters of solution, and this will tell me the molarity of silver ion in solution. And the molarity of silver ion in solution will represent the moles of the solid that dissolved into a liter of solution. So I get 1.35 10 to the negative fifth molar silver ion, which is also the molar solubility, because for every 1 mole of silver ion found in solution, 1 mole of the silver chloride must have dissolved into solution, and that is the definition of molar solubility, the moles of the solid that dissolved in a liter of solution, here represented by the moles of silver that dissolved in a liter of solution.